Hey, what's up everyone? So we're going to go over MusiCode Lesson 3 today. So I'm here in my MusiCode V12 clone, and go ahead and click on Run on Free Compute, and then it'll open up your directory, and go ahead and select Lesson 3. Okay, so first thing we should do is restart and run all, and so we can go up to kernel, and then restart and run all. So remember what this does is it's going to clear the output, and it's going to run every cell of code. So we can see right now it's running the setup code. And so just as a reminder, this is going to install sound file, which allows us to work with WAV files. MusiCode V12 needs to be imported, and then we initialize MusiCode right here so that we can utilize the create wave function. And so this needs to be at the top of every Jupyter notebook where you are running MusiCode. All right, so let's get into the create wave function. So this is a fundamental function of MusiCode, and a lot of other functions like sequence, chord, and arpeggio all rely on create wave. So let's just go ahead and look at an example. So we have an example here. We have the variable named waveform, and then we're calling create wave off of the m variable, which was defined here. So if you don't run this line of code, then this will not work. So make sure you got your setup code. So we're calling create wave, and there's three inputs that we're passing into this. The first is note labels. The second is going to be the waveform type, and then the duration. So I want to focus on note labels first. So you can see here that this is actually a number. So you're able to pass in either a number for frequency, or you're able to pass in a string with a note label like this. So there are two different ways. So if for some reason you want to use frequency rather than just a musical note, you can do that. So we have our waveform type here, which is a sine wave, and then it's going to last for a total duration of an eighth note at 120 beats per minute. And so it's really critical to understand that all of the duration and rhythmic values are derived from the beats per minute that's set here. And so an eighth note at 120 beats per minute is going to be a different number of seconds than, if this were 250 beats per minute. So just keep that in mind that this is not absolute time. We're now working with relative time depending on the BPM. All right, so once we create our waveform, we can bounce it out like this, and then we can hear it. There we go. Cool. So another example here, to create a sub bass, we're going to pass in 50. So 50 hertz is a pretty good sub frequency. Sine wave is always a good idea for any sub bass, and then duration is 1/8. So we can see the frequency is much larger, or I guess the frequency value is 50 compared to 440. But we can see that there's fewer peaks here. And so if you hit play, you probably won't be able to hear it unless you have a sub bass, or if you have some sort of subwoofer. Okay, so next we have just a more typical example utilizing a note value. And so one thing I want to make clear is that we have these square brackets which should always surround the note labels, because note labels is supposed to be a list. And so if you were to do this, you will actually get an error. It's going to say key error because it's expecting that this is going to be a list. So make sure you have your square brackets there. And this allows you to pass in multiple notes, which I'll show you in a minute. All right, so we use a triangle wave, and then we have duration equals 1/8. And then notice how we're bouncing this. We use the variable name, and then we call the bounce function off of it. And so there's a few ways that you can use this bounce function. If you pass in a name here, it's going to name that file whatever you pass in here. If you do not name it, then it's going to essentially generate a name that's called like user playback with a number. So if it's really important, make sure you give it a name. If you're just kind of monitoring the sound, you don't have to always name things. Okay, another useful one is the rest. So to create silence, we use m.rest. So we pass in, again, a rhythmic value depending on the BPM, like that. And then we have this .view function, which is going to allow us to, essentially look at the waveform and plot it. Okay, so a little bit more about BPM and relative duration. So remember that these are all of the rhythms are synced to the BPM. So we can see here that when we initialize MusiCode, we're required to pass in a BPM. You can also change the BPM using this right here. So m.set BPM. Say I wanted to make it 250, I could do that. And then shift enter to run that cell. Okay, so here we can see that we're passing in multiple notes. So this is a list of string values. So this is going to create a C major chord, which we can listen to here. Cool. So in the next example, you can see we're just continuing to pass in lists of notes, and you can pass in as many notes as you want, and they will all be, added together into one waveform. All right, cool. So just a few more examples there. Okay, so we're able to do mixing, and we're able to adjust volume, because if something is way, way too loud or so quiet that you can't hear it, that can be problematic. So the way that we work with volume is we first define a wave, and then we have dot VOL for volume, and then we pass in the multiple that we want to adjust the volume by. So right now, this is going to be 2 times as loud. So I'm taking the original signal and I'm doubling the volume. If I were to do something like 0.5, this is going to be 50% volume. So cut the volume in half. And so if I were to do volume 1, this is going to not change the volume at all. So make sure you have a good grasp on that. And you can always throw it into a waveform to really have more control over the volume. So another aspect of create wave is the wavetable position. So this allows us to create more complex waveforms, or it allows us to slightly modulate the different waveform types to create different timbres. And so you can see just the difference between something like this and then a more conventional sine wave, or just a standard sine wave, would look like this. So you'll notice a big difference just in the overall timbre. So we can see the nice smooth right here, and then we have these notches. So this is going to create a different timbre, but the frequency will stay the same. Cool. Okay, so a few other things. You're able to pretty much adjust the wavetable position to adjust the timbre. And there's a few more examples of as you increase the wavetable position even more, what happens to it. You start to get these lines as we push it up to 77,000, we get this. And you can listen to this and you'll hear kind of like a noise that's created. It's a really interesting way to kind of experiment with different timbres. Cool. All right, and then here we have an example that shows kind of the difference in the sound. And so we can listen to the first waveform. And then this is with wavetable position equals 99. And then when wavetable position equals 999, we get this. So these are all coming from a sine wave, as we can see here, but we've adjusted the wavetable position to create that difference in timbre. Notice that when you use this, it often gets louder. So in this case, I just made these 40% volume just to make it a little bit more even. All right, so that is the create wave function, and we'll be using this a good bit. We'll primarily be using other methods which utilize this, and so we will get into that in the next video, and I will see you there.